In 1944, two American scientists lowered a hydrophone, an underwater microphone, into the Pacific Ocean. They weren't looking for anything in particular. What they found changed how we understand the entire planet. They discovered that the ocean has a layer, a specific channel of water, roughly a kilometre below the surface, where sound doesn't just travel, it travels forever. A single sound made in that layer has been tracked crossing entire oceans, thousands of kilometres, without losing its signal. And for hundreds of millions of years, the creatures living in that layer used it to do something extraordinary. We just broke it. The ocean is not silent. It never was. For hundreds of millions of years, the deep ocean has had its own acoustic infrastructure, a natural sound channel that works like a global telephone network, letting animals communicate across the width of entire ocean basins. Blue whales talking to each other from opposite sides of the Pacific. Earthquake signals being detected thousands of miles away. The planet literally humming. And in the last 70 years, specifically since the 1950s, when global shipping exploded, we have increased underwater noise levels by a factor of 100. Not double, not 10 times, 100 times louder. This is the story of what that channel is, how we broke it, and what's happening to every creature that depends on it. So let's start at the beginning. The ocean is not one uniform body of water. It's layered. Temperature, salinity, and pressure change with depth, and those changes do something fascinating to sound. Sound travels at different speeds through water depending on those conditions. Warm water near the surface speeds it up. Cold water deeper down slows it. But then, as you go even deeper, increasing pressure speeds it back up again. That creates a minimum, a depth, typically somewhere between 600 and 1200 meters, where sound travels at its slowest. And here is where the physics gets extraordinary. Sound always bends towards slower water, so any sound entering that low speed zone from above gets bent back down. Any sound entering from below gets bent back up. The channel traps sound inside itself like a waveguide. Scientists named it the SOFAR Channel, sound fixing and ranging, and when the US Navy first tested it in 1960, they detonated a small explosive charge off the coast of Perth, Australia. The sound was detected 19,000 kilometres away, in Bermuda, across an entire ocean, from a small explosion, detected perfectly on the other side. The SOFAR Channel is essentially the ocean's own global telephone system, and it has been running, with no maintenance required, for hundreds of millions of years. Blue whales figured this out long before we did. Their calls sit at 10 to 40 hertz, below the range of human hearing, and they produce them at depths that feed directly into the SOFAR Channel. A single blue whale call can be detected by another whale on the opposite side of the Pacific Ocean. They're not just communicating, they're navigating. They're coordinating migrations across distances that are almost impossible to comprehend. The ocean has a built-in communications superhighway, and it took us about 25 years after discovering it to start filling it with noise. Here is where the story takes a turn, because the SOFAR Channel doesn't just carry whale songs, it carries everything. And since the 1950s, we have been filling it with an extraordinary volume of mechanical noise. A modern container ship, the kind that moves the phones and clothes and cars that stock our world, produces around 190 decibels of underwater noise at the source. To put that in context, a rock concert speaker puts out about 120 decibels in air. The physics of water makes sound roughly 60 decibels more intense for the same physical pressure. Container ships are extraordinarily loud, and there are now roughly 90,000 of them crossing the world's oceans at any given time. Researchers at the Scripps Institution of Oceanography compared recordings from the same ocean location taken in the 1960s and again in the 1990s. The ambient noise level, the background hum of the ocean, had risen by 20 decibels. That sounds modest, but decibels are logarithmic. 20 decibels is not 20% louder, 20 decibels is 100 times louder. But shipping is not the only source. Oil and gas companies use seismic air guns to map the seafloor for reserves. These devices fire compressed air pulses at 250 decibels. Military sonar operates in the 1 to 10 kilohertz range and is well documented to cause cetaceans to strand on beaches, apparently fleeing the noise in blind panic, surfacing too fast, suffering injuries consistent with pressure trauma. And all of this noise sits directly in the frequency range, 10 to 500 Hz, that the ocean's largest and most acoustically sophisticated animals evolved to use. Which brings us to the most important question. What happens to animals whose entire world runs on sound, when the silence they evolved in is replaced with permanent noise? There are roughly 350 North Atlantic right whales left alive. That is not a typo. 350. And research from Cornell University has shown that their acoustic communication range, the distance over which they can hear each other, has collapsed from around 1,000 kilometers in pre-industrial times to less than 100 kilometers today. For a whale that uses sound to find a mate across an ocean basin, that is not an inconvenience. That is an existential crisis. The ocean is the same size. The whale is now acoustically alone. Blue whales, the largest animals ever known to exist on this planet, have actually been changing their calls. Over the past 50 years, their call frequencies have shifted downward by roughly 30%. One hypothesis is that they are actively compensating for the noise, pushing their voices into frequencies the ships haven't yet colonized. Think about what that means. Animals are physically adapting their communication under the pressure of our noise, and they don't have unlimited range in which to move their voices. The effects go deeper than communication. Studies on belugas and bottlenose dolphins exposed to chronic shipping noise show elevated levels of cortisol, the stress hormone, along with immune suppression and disrupted reproduction. These animals are not just unhappy. They are physiologically breaking down under constant acoustic stress. And it is not just mammals. Research published in Nature Communications showed that larval fish, baby fish, just settling from open water onto reefs, use the soundscape of the reef to navigate. They literally follow the sound of a healthy reef to find their home. In noisy ocean conditions, they lose that signal. They don't find the reef. They don't survive. The ocean's food web depends on sound in ways we're still discovering. And the sound is going wrong. There is one piece of this that is genuinely hopeful. Research has shown that simply reducing ship speed by 30% cuts underwater noise output by 75%. The technology already exists. The knowledge already exists. The main obstacle is economic and political will. The ocean has had an acoustic infrastructure running for hundreds of millions of years. A sound layer that carried whale songs across oceans, guided larval fish home, let the planet's largest animals find each other across impossible distances. In 70 years, we increased the background noise by a factor of 100. The whales are changing their calls. The right whales are disappearing. The fish are lost, and slowing down ships, just slowing them down, cuts 75% of the noise. The fix isn't complicated. It just requires knowing the problem exists. Now you do. If this made you think differently about something you've never seen, hit subscribe. Every week we find the invisible science hiding behind the world around you and show you exactly what's happening. Drop a comment. What ocean fact genuinely surprised you?